Hi everyone, today I want to discuss with all of you how a vector changes when it rotates. So imagine you have a vector, let's call it a bar. So I'm assuming you know about vectors. If you don't know, I will share a link in the description. You can see that video to understand what is a vector. So imagine this is a vector whose magnitude is given by this length, right? And direction is given by the arrow wherever it is pointing. Now let's say I rotate the vector around this point. So around this point I rotate the vector. So let's say I rotate it by some angle theta. So this is my new vector. Now are these two vectors same? Now magnitude is same but direction has changed. So vector has changed. So if I call this vector a bar, this vector I cannot call it a bar. It has to be something else. Let me call it a1 a dash bar. So what is the change in the vector? So the change in the vector is given by this vector. So this arrow gives you the change in this vector. So delta a bar. Why this represents the change in the vector? Why, sir? We'll just use your triangle law of vectors. You all know this vector plus this vector is this vector. So this vector plus this vector is equal to this vector. So this vector must be a bar dash minus a bar. And since a bar dash is the final vector and a bar is the initial vector, right? This is before rotation, this is after rotation. And after minus before, final minus initial always represents change, right? So that's why we call this quantity, this vector, as change in vector. Now suppose you know the length of these two will be same. So that means the length of vector a bar, the modulus of vector a bar, modulus means the magnitude of this vector is same as magnitude of this vector, which I can represent by simply a. So length of both of them are same, a. Now I want you to tell me the length of the change in vector, the magnitude of this vector. Well, you can use the formula for magnitude of difference of two vectors. This is nothing but difference of two vectors. So you have the formula for magnitude of difference of two vectors. You can use that. But a smarter way to do is using trigonometry. How? Divide this whole triangle into two equal triangles, right angle triangles. Now if this angle was theta, this angle will be theta by 2, this angle will be theta by 2. Remember, I want to know magnitude of this vector. So I want to know this length, right? Length of the vector is magnitude of the vector, don't forget. So let us try to call this as A, B, C. So I want to know this length BC. Well, this midpoint, let me call this point as M. Then BC, this whole length is nothing but twice of BM. Because this side is BM, this side will be same as BM. Sidewise it is same. So BM plus BM will be 2BM. Now what is this BM? If you look this triangle separately here, this is your A, this is B, and this is M, the midpoint of BC. This whole length is magnitude of a bar. This length is magnitude of this vector which I wrote as a. This angle is theta by 2. So if I write sine theta by 2, then you know sine is opposite by hypotenuse. So this opposite side is BM, hypotenuse side is AB, which represents the length of this a bar, which is simply a. So cross multiply. What is BM side? A sine theta by 2. And BM is a sine theta by 2. So what is BC? Length of this vector, delta a bar. And length of delta a bar means magnitude of delta a bar. So this formula is very, very useful. So when you have a vector of magnitude a and it changes by rotating around its tail, so magnitude remains the same. So A I wrote. Here I wrote a bar dash. That is because I wrote as bar. So when you write bar, it represents a vector, and these two vectors are not same. So I cannot write a bar, right? So I have to give different symbols. But magnitude is same. When you rotate, the length will not change. So this angle by which it rotates is theta. Then what is the change in the vector? This arrow represents the change in the vector. And if you want to know the magnitude of the change in vector, there is simple formula 2a sine theta by 2. So a is the magnitude of the vector which is changing, and theta is the angle by which it rotates. Okay. Now one final thing I will say you, this formula is to calculate magnitude of change in vector, not change in magnitude of vector. This is different. If they say change in magnitude of the vector, that is 0. Why? Because magnitude did not change. So final magnitude is A, initial magnitude is A, this is 0. Right? So this is understand not change in magnitude, this is change in vector. And vector has clearly changed because direction has changed, right? Let us apply this concept to a simple question. So you have a particle which is going in a circular motion, and this uniform circular motion. So the speed remains constant. Speed meaning the magnitude of velocity. So when the particle is here, its velocity has magnitude 5 meter per second in this direction, and the radius is 2 meter. When a particle comes here, it rotates by 74 degree, and when it reaches here, its velocity has same magnitude 5 meter per second, and obviously radius is also same 2 meter. You need to find displacement and change in velocity, right? Now if you think carefully, what is the meaning of displacement? Displacement simply means a vector from initial position to final position. So here was initial position, here is final position, so this is displacement. Let us call this vector as S bar. So they want displacement vector magnitude. Now think carefully. This, if you consider as one vector, like this vector was, it has turned by 74 degree like this vector has turned. So this represents the change in these two vectors, right? This minus this. And that represents this vector, isn't it? Think carefully again. This vector, let us say this is O. So OA is like this, OB is like this, and the displacement which they want is like this change in the vector. So direct formula we can use 2a. A matlab length of the vector which has turned. Here the vector which has turned has what length? 2 meter. So 2 into 2, this A is 2. Sine of angle turned is 74 by 2. This is 74. 74 by 2 will be what? 37 degree. And 37 degree is a very simple angle for physicists, right? Because we know that famous triangle, if this is 37 degree, this is 3, this is 4, this is 5, isn't it? So this is 4 into sine 37 will be what? 3 by 5, opposite by hypotenuse. So answer is 12 by 5, which is 2.4 meters. Why meter? Because this 2 was in meter, remember. Okay. So that is the answer for displacement. Immediately we can find, right? No need to do all that magnitude of difference of vectors. Now, let us discuss change in velocity. Now, this vector represents the initial velocity. 5 meter per second was the magnitude of this velocity vector, that means length of this vector. Now, that velocity has turned and became this velocity, isn't it? Magnitude of this velocity is also 5. So remember, this was the velocity. Now this is the velocity. This was the initial velocity, you can think, and this is the final velocity. So can you see velocity vector also turned? The length remains the same because this is uniform circular motion. So magnitude will be same. Now what is the angle turned? Well, that will be also same 74 degree, right? Now why should this angle be also 74 degree? Well, if this was your circular path, then when the particle was here, this was the radius and this was the velocity vector initial. After some time when particle came here, this was your velocity vector. Now can you see that this velocity vector is perpendicular to this radius vector, because this is tangent and this is radius, and this velocity vector is also perpendicular to this radius. And when two vectors are perpendicular to another two vectors, the angle between those must be same. Meaning, if this angle is theta and this angle between the velocity vectors, okay, this velocity and this velocity, okay, this velocity and this velocity, so that angle will be also theta. Why is it so? Well, that's simple geometry. Take two lines, 1 and 2. Now draw perpendicular to 1 and 2. This is perpendicular to 1 and this is perpendicular to 2. So 2 and 2 are perpendicular, right? You can see 1 and 1 are perpendicular. Now if this angle is 30 degree, this angle should be how much? Remember, this is 90, this is 30, this is 90, so this must be 60. This is also 90, so if this is 60, this part will be 30. So this angle and this angle must be same. So if two lines make angle theta, their perpendicular lines will also make angle theta. Therefore, this velocity and this velocity, which are perpendicular to this radius and this radius, will make same angle as the angle between the two radius. Okay. So this angle will be 74. Now remember, this is the initial velocity like this vector was, and this is the final velocity like this vector was. Like this vector turned, this vector also turned. So change in the vector, or in this case change in the velocity, will be this vector. So this is the change in the velocity vector, and whose magnitude they want. So the formula will be 2a. What was a now? The length of the vector which is turned. Here the length of the vector or magnitude of the vector which is turned is velocity, right? Because we are calculating change in velocity. This was change in a bar and this was a. This is change in velocity vector. So this should be v, magnitude of v bar, which is 5, into sine, angle is 74 degree only. So 74 degree by 2 will be 37, isn't it? So this will give you 10 into sine 37 from here will be 3 by 5, and that will be 5 2s are 10, 2 into 3, 6 meter per second. Now let me show you a very interesting result. Change in velocity vector. What is the formula? 2v sine theta by 2, isn't it? Right? So when your velocity turns by angle theta, of course the radius has turned, but velocity also will turn by same angle, then the change in the velocity is given by this formula. Now if you divide the change in velocity by time taken, that would be your average acceleration. Okay, average, because this interval is large. So 2v sine theta by 2 divided by this time taken. Now how to find this time taken? Well, it is going with constant speed. Remember, speed is constant, velocity is changing because velocity is vector, but magnitude of velocity, which is speed, is constant, v all the time. So speed definition is distance by time now, and this is the distance covered. And you know from mathematics that if the radius is r and angle is theta, the arc length, which is nothing but distance, is r into theta. So this distance is r into theta divided by time taken from here to here is delta t only. So speed, I have used what formula? Distance by time. And since it is constant, average speed, instantaneous speed will be same. So though this is average speed, it will be same as instantaneous speed. So what will be time taken? R theta by v. Substitute this here. R theta by v. Right? So now this v will go up. So the average acceleration will be 2v square sine theta by 2 divided by r theta, right? Let me bring these two here. Why? Something interesting will come. So these two I wrote in the denominator of denominator. Of course it will go in the numerator, but keep it like this. Now why I am keeping it like this? Well, in circular motion, if you want to find instantaneous acceleration, instantaneous, this is average, then what we need to do? To find instantaneous acceleration, I need to just take the limit of the average acceleration and I need to make sure the time taken tends to 0. Why time taken should tend to 0? Because I want at a particular point in the motion. So at a particular instant, if you want the acceleration and not average acceleration between two instants. So this is average acceleration between two instants. I want instantaneous acceleration at one instant. One instant. Then time taken has to be very small. Those two times should be very close to each other. So your time interval should be very small. Now in this formula, what does it mean when I say delta t should be very small? Remember, theta was the angle covered by the particle when it went from here to here. Now if you make the time interval very small, then the particle will go from here to only here. In that case, this angle theta will be very, very small. And you know from mathematics, and if you don't know, don't worry, you will come to know in class 11 mathematics, that sine x by x, when x is very small, when x tends to 0, okay, this angle part, when that angle becomes very small, this ratio becomes 1. Okay, ask your mathematics teachers. So therefore, when your time interval becomes very small, this angle becomes very small, and this sine x, think of theta by 2 as x, then sine x by x, that's why it was important for me to bring these two downstairs. Okay, so sine x by x will be what? When this theta becomes very small, so this x will be very small, then that ratio will be 1, and then the answer will become v square by r, and this ratio will be 1 when your time interval is very small. And that is the formula for instantaneous acceleration when particle moves with uniform speed. And please let me know in the comment what is this acceleration called.